Hello dear students, welcome once again to our channel Maths in Minutes with Priya. Today it's clip 90, Time and Speed part 8. Today we are going to learn few basic concepts of boats and streams topic. Before you watch this topic, I would advise that you watch first 7 parts of time and speed, because all the principles of time and speed, like speed is equal to distance upon time, average speed, etc., we are going to use to solve the problems based on boats and streams. So it will be better if you watch first 7 parts first before you start watching boats and streams. First, let us understand the terminology that we are going to use while solving the problems. When first I learned boat and streams, I used to get scared of this topic. समझ में ही नहीं आता था कब किस में क्या ऐड करना है, because there is additional element of speed of stream and speed of boat. Two elements are there now. In earlier example, what happens of time and speed? Time, speed and distance, only 3 quantities are there. But now in speed, 2 elements extra are added. So I used to feel कि बाप रे ये कितना difficult topic है. But once I started solving, once I understood the basic concepts, this topic became very easy, and actually it's easier than rest of time and speed problems, because there are only 4 formulae and they are very easy to remember, nothing difficult, and solving becomes very easy. So today I am going to concentrate on all basic concepts and basic examples of boats and stream. Once you understand that, then the next part we will solve the advanced examples and you will see that how easy it becomes. So now let's begin today's topic. First, let us understand these terms. Speed of boat in still water. Now this water is still. Still water means water is not moving. Water is still. And this man is rowing the boat, or this man is swimming. Both cases are possible. In that case, whatever is the speed of boat, with that he will move ahead, or whatever his own speed he is swimming, with that he is move ahead, because water is still. Water is not moving. So सिर्फ उसका जो boat का speed है या उसका खुद का speed है, that will only matter. So we are going to call it as SB, speed of boat in still water. It is SB. But sometimes water also flows. हमेशा water still रहेगा ऐसा नहीं है कि नहीं? Sometimes water also flows. In that case, this is known as speed of stream. बहता रहता है पानी. कुछ speed उसका खुद का भी एक speed रहता है. That is speed of stream. That we are going to call it SS. Speed of boat SB. Speed of stream SS. This is also known as speed of current और current rate. ये जो पानी का current रहता है उसको current कहते हैं, stream कहते हैं या current कहते हैं, कुछ भी कहते हैं. Meaning is same, speed of stream. Understood these both concepts? So either water is still or water is flowing. Both cases are possible. Now what happens if water is flowing and in the same direction boat is also moving? Water is flowing in this direction and boat is also moving in this direction. So this water will also help the boat to move ahead. Am I right? Water is also flowing, boat is also flowing, both are moving in same direction. That means this water will help boat to move faster. So this is known as downstream. This concept is known as downstream, and speed downstream is sum of speed of this stream plus speed of this boat, because this stream helps boat to move forward. दोनों का speed add हो जाता है और boat fast आगे चली जाती है. So speed downstream is equal to sum of speed of boat in still water plus speed of stream. Add हो जाता है. Now what happens if the case is reverse? Water is flowing in this direction, but this boat is flowing in this direction. Against जा रही है, उल्टा दिशा से. तो क्या होता है? This water, it resists the boat. It tries to stop the boat, and this man has to रो विथ मोर स्ट्रेंथ, उसको ज़्यादा ताकत लगती है रिवर्स जाने के लिए. सो क्या हो जाता है, स्पीड ऑफ अपस्ट्रीम, दिस इज नोन एज अपस्ट्रीम. स्पीड ऑफ अपस्ट्रीम, दिस वाटर इट अपोजेस द बोट एंड हेंस स्पीड अपस्ट्रीम रिड्यूसेस, कम हो जाती है, एंड स्पीड ऑफ बोट माइनस स्पीड ऑफ the stream that becomes speed, sorry this should be SU not ST, SU, speed upstream. Speed upstream is speed of boat minus speed of stream. Yes, speed of stream it opposes, it resists the boat, and hence speed of boat minus speed of stream is equal to speed upstream. You got the meaning of speed downstream and speed upstream. We are going to call it as SD and SU, downstream, upstream. For downstream, boat and stream their speeds get added, whereas for upstream जब opposite जाती है, then speed of boat minus speed of stream, that becomes speed upstream. You understood these four basic things: SB, SS, SD and SU. Understanding this is very important. Please pause this video in between, rewind it and watch it again so that you will understand these terms. Now let us see how to use these terms in formulae. Just now we saw these two formulae. Speed downstream is sum of speed of boat and speed of current, and speed upstream is SB minus SS. अभी ये दो फॉर्मूले देखे, ये बाय हार्ट कर लो. अरे बाय हार्ट करने की भी ज़रूरत नहीं है, वंस यू अंडरस्टैंड इट्स मीनिंग वो याद रह ही जाता है. नाउ फ्रॉम दिस ओनली वी आर गोइंग टू डिराइव टू मोर फॉर्मूले. सी हाउ. इफ आई एड दिस टू इक्वेशंस, व्हाट विल हैपन? SD plus SU, and right hand side mein this is plus SS and minus SS, so this will get eliminated and 2SB will be left on the right hand side. So SD plus SU is equal to 2 into SB, and therefore SB is equal to नीचे लेके जाओ, SD plus SU upon 2. ये हो गया तुम्हारा थर्ड फॉर्मूला. So basically this formula is derived from this only, कोई अलग से ऐसा फॉर्मूला नहीं है. And there is one more formula. For that what we are going to do? We are going to do this 1 minus 2. अभी हमने किया 1 plus 2 and we got this third formula. Now let us do 1 minus 2. Then what will happen? SD minus SU. And in the right hand side, SB will get eliminated and SS plus SS हो जाएगा 2SS. Take this 2 in the denominator. So SS will be SD minus SU upon 2. This will be the fourth formula. So 1, 2, 3, 4. Just remember this 4 and your topic is done. Got it? Now let's solve few problems based on this formula. Ravi can row upstream at the rate of 12 kmph, downstream at 20 kmph. Find Ravi's rate in still water and rate of current. So what quantities are given to us? SU is 12 upstream, SD is 20 downstream. Always remember speed downstream will be more than speed upstream. Naturally, because in downstream water helps the boat to move and in upstream water opposes the boat to move. So speed downstream is always more than speed upstream. ये याद रखना. Sometimes when you calculate, if you get it otherwise, like if you get speed upstream more than speed downstream, then be sure that somewhere your calculations are wrong. So take that care. So these two quantities are given to us and question is about rate of current, that is SS, and rate of boat in still water, that is SB. We want these two quantities. Now very easy formula are there. What is SB? Look at our formula. SB. SD plus SU upon 2. So what I am going to do? I am going to add these two and divide by 2. 12 plus 20 upon 2, that is 16. And for SS, it is SD minus SU upon 2. So 20 minus 12 upon 2, that is 4 kmph. Now this is a very basic problem, but today we are going to do basic problems only so that this formula get fixed in your mind. उसको use कैसे करना है, so that when we solve advanced level problem तुमको बार बार formula refer करने की ज़रूरत नहीं है. You will remember everything. Let's solve 2-3 more problems. Ramesh can row upstream at 32 kmph and speed of stream is 4 kmph. Find his speed downstream. So what quantities are given to us? SU is given to us, upstream speed. SS is given to us, speed of stream, and we are asked SD. From these two quantities, what is the third quantity that we can get? We know this formula. Speed of upstream is what? Speed of boat minus speed of stream. So let us substitute this. 32 is equal to SB minus 4. With that we get speed of boat as 36. Now we know speed of boat, we know speed of current, so we can just add them and we can get speed downstream. So we are going to use this two formulae here. 4 formulae we have learnt, and out of that 2 formulae we are using here. So this is 36 plus 4, so answer is 40. 40 kmph. That's your answer. Very easy. Let's move to next problem. Speed of a boat in still water is 4 kmph. Speed downstream is 20 kilometer. This should be 20 kmph. 20 kmph more than speed upstream. Find the downstream speed. So speed of boat in still water, SB is given to us. Difference between downstream and upstream is given to us, 20, and we are asked what is SD. So what we can do here, with this difference we can use this formula. SD minus SU upon 2 is 2SS. So 20 upon 2, this difference is given to us. Separate speeds are not given to us, downstream, upstream separate are not given to us, but their difference is given to us. So we are going to use this formula. With that, using this formula we get speed of stream, 20 upon 2, that is 10. Speed of stream is 10. Now can we find speed of downstream? Speed of stream plus speed of boat, that is speed downstream. So 10 plus 4, that is 14. That is speed downstream. See, these problems are oral, and once you understand upstream, downstream, boat stream, एक बार ये दिमाग में फिट हो जाएगा ना, फिर ये फॉर्मूला बाय हार्ट करने की कुछ ज़रूरत ही नहीं पड़ती. Just see the information, do oral calculations and give your answer. इतना easy हो जाता है. But then it takes a little while to understand these concepts. Downstream, upstream, still water, speed of stream, ये 4 concept आ जाते हैं तो थोड़ा दिमाग घूम जाता है. So it takes few minutes to understand this concept, but once you understand, then it's a cakewalk. So spend some time in understanding the concepts, फिर ये boat stream एकदम easy हो जाएगा. Now let's learn one more concept. Let's see few comparisons. Some time back we discussed that speed downstream is always more than speed upstream, because in downstream the river helps the boat to flow in the same direction, hence speed downstream is always more than speed upstream. What does this indicate? This indicates time taken for downstream will be less than time taken for upstream. Since speed is more, वो फटाफट आगे चली जाती है, फटाफट बोट आगे चली जाती है, and hence time required downstream will be less than time required upstream. ये 2 बातें याद रखना. Now look at this picture. Suppose this is a lake or river, whatever. These are 2 banks of rivers. Here is one tree, here is another tree. Say P is one bank of river, Q is another bank, and the distance between them is D. Now a person can go from P to Q. Water is flowing in this direction. So from P to Q it is downstream. From Q to P it is upstream. But in both cases, distance is common, that is D. From here to here or here to here, upstream, downstream, but distance is common, that is D. One more thing to understand here is, if I tell you, in this case, in this particular case, say if I am telling you speed downstream is 2 times that of speed upstream, मतलब स्पीड डाउन स्ट्रीम इज डबल दैट ऑफ स्पीड अपस्ट्रीम, वो डबल फास्ट चला जाता है आगे, दैट मीन्स टाइम रिक्वायर्ड डाउन स्ट्रीम विल बी हाफ ऑफ टाइम रिक्वायर्ड अपस्ट्रीम. So time required downstream will be half the time required upstream. If this is 2, this will be half. स्पीड डबल है तो टाइम हाफ है, स्पीड 3 टाइम्स है तो टाइम 1/3 है, बिकॉज डिस्टेंस इज सेम. यहाँ से यहाँ, यहाँ से यहाँ, डिस्टेंस इज सेम, एंड हेंस फ्रॉम हियर टू हियर इफ स्पीड इज डबल देन टाइम रिक्वायर्ड विल बी हाफ. From here to here, if speed is 3 times, then time required will be 1/3 of upstream. This is also T. If speed downstream is 3 times that of speed upstream, then time downstream will be 1/3 that of time upstream. If speed downstream is 3 times that of speed upstream, then time required downstream will be 1/3 that of time required upstream. Understand this. And if I tell you time required upstream was 3 times that of time required downstream, that means speed upstream is 1/3 that of downstream. उल्टा हो जाता है. Getting it? So speed and time, the relation between them will be inverse relation since distance is same. Since distance is same, speed अगर कम लगता है इसका मतलब टाइम ज़्यादा लगता है, स्पीड ज़्यादा है इसका मतलब टाइम कम लगता है. प्लीज़ ट्राई टू अंडरस्टैंड दिस. एंड ऑल्सो दिस बेसिक टर्म स्पीड अपस्ट्रीम इज व्हाट? डिस्टेंस अपॉन टाइम अपस्ट्रीम. स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम. स्पीड डाउनस्ट्रीम विल बी डिस्टेंस अपॉन टाइम जो डाउनस्ट्रीम में जाने लगता है. अगेन अंडरस्टैंड दिस टू टर्म्स. Now let us solve one problem based on this concept so that you will understand it fast. Downstream speed of a boat is 20 kmph. If the time required for downstream is half the time required of upstream for crossing a lake, then find the speed upstream. What do we understand from this? Have they mentioned any distance? They haven't. See, speed is given, you need to find time, so naturally we need another quantity, that is distance. But here distance is not at all mentioned. But what they have mentioned? For crossing a lake. So for upstream and downstream, in both cases distance is same. So when distance is same and relation between time is given to you, can we find relation between speed? Just now we learned this concept. They are saying time downstream is half that of time upstream. That means speed downstream will be double that of speed upstream. If this is half, उसका reciprocal बन जाता है 2. If this was 1/3, this will be 3. If this was 1/4, this will be 4. Getting it? So this is half and this is 2. Speed downstream is given to us as 20. So 20 is equal to 2 into speed upstream. So speed upstream is 10 kilometers per hour. With this relation, we can find the speed. Understood how to use this concept of inverse relation between speed and time for solving this type of problems? In next part, we are going to solve little advanced level problems, and we are also going to learn few shortcut formula are also there. But as you know that I always rely on concepts more than shortcuts, because ये shortcut कभी-कभी दिमाग में mix हो जाते हैं. So I'm going to teach you concept method as well as a shortcut method in next part to solve few advanced level problem. So please keep watching. If you haven't yet subscribed to my channel Maths in Minutes with Priya, please do so. It's absolutely free. So see you in the next part. Till then, stay happy, stay blessed. Bye for today.